All right. So these are my critters, Allegra and Claritin. Um, Now, about a year ago, I started a project. I started a Pinterest board called Guinea Pig Fairy Village. My critters have a fairly large cage, but I dream bigger. My vision was that instead of just having a regular cage, they could have something that was, I don't know, somewhere between like the Keebler Elf tree and the village from The Hobbit. Um, and then I thought, like, well, guinea pigs are social animals. If I'm building a hobbit village, then why stop at 2 critters? Why gotta have a whole colony of them? I hit some roadblocks almost immediately. Now, 3 problems. One, as their name suggests, I am quite allergic to them. Uh, 2, given I can barely clean up after 2 guinea pigs, there's no way I'm going to keep up with like a whole village. And 3, I am not particularly handy, and I don't think that they sell this at IKEA. Um, but I'm a programmer. I'm a problem solver. I might be a lazy slob, but I can work with that. So at first I think, well, maybe I can just release a bunch of dung beetles into the village, and I can just let nature take its course. But then I think, why would I build anything at all? I'm a programmer. I could make a virtual guinea pig village. My critters could live in cyberspace. And then when I start thinking on this, I think, no. If I could do this as an app, I could do in-app purchase. It could be, this could take off. I could start making the Kim Kardashian bucks. But before I get to all that, I'm not here to talk about getting rich with free-to-play games. I am here to talk about my design process. And now in the last couple of years, I've seen an interesting progression. I mean, I used to be, full stack, but a lot of what I was doing in the full stack has moved to the front end. But even though the work has shifted entirely client side, I'm still applying the same client server patterns within the client, just at a smaller scale. It's like, yo, dog, I heard you like client server architecture, so I put, And as I've gotten into the React ecosystem, I keep seeing things like this in parallels between what we do on the client and what we used to do in the whole system. And I'll encounter something quote unquote new like FRP or event sourcing or sagas, only to discover that they've been around for like 20 or 30 years in the back end world. And this got me thinking about the history of ideas and the way that they spread and mutate. The everything is a remix. So as I walk through my design thinking on this virtual critter village, I'm going to try and trace the history of these patterns and ideas. My hopes are that if we can recognize the parallels between then and now, we'll be able to identify where things can go wrong without having to make those mistakes all over again. So let's call this project Critterville. Hopefully I can think of a better name before I get a cease and desist from Zynga. Now in this game or toy or whatever it is, the goal is that you build a village for guinea pigs with fixtures like food dishes and houses and toys and stuff. And your goal is to attract critters to the village and then keep them fed and healthy and happy. Now, as far as how I'm modeling the critters, guinea pigs are not particularly sophisticated animals. They have, the way that I'm modeling this with very, very simple behavioral feedback loops. For example, when they cross a hunger threshold, they'll try and eat food. Also, they poop constantly, which the user needs to clean up. Happy and well-fed critters are friendly to you and each other, but agitated and hungry critters get aggressive and eventually leave the village. So I think I'm ready to start speccing this out. But where do I begin? What kind of artifact do I want to use as my reference? There's a couple of different design approaches I've seen. Now, I used to work a lot in agencies, and the design process seemed to be I would get a mock-up and then be told to work down the stack from there, where I'm supposed to figure out how it works based on what it looks like. Now, there's obvious problems with that, but I think the opposite approach doesn't work either. A lot of times when engineers are tasked with cataloging requirements, we think, okay, we'll make an ERD, and we'll have this giant database schema, and we'll figure everything out beforehand, then we'll build up the stack from there. And I get why people follow these approaches, but I see kind of 2 major problems with them. First is that they commingle the ideas with the implementation. I want to map out the problem of modeling a guinea pig village. And that has nothing to do with page layout or whether I use a varchar instead of a text. Second, both comps and database schemas, they answer what it is, but not so much what it does. In addition to like the facts, I also want to identify things like what are the commands I can issue, what are the questions I can ask. In other words, like what are the messages between me and the computer going to be? So the design artifacts that I'm going to start with, the sort of like the core principle of this guinea pig system is a vocabulary of these facts and messages. And I don't think of these as technical terms. This is not implementation details. This is all about the domain of the problem. This is an idea I'm lifting probably incorrectly from Eric Evans's domain-driven design's ubiquitous language. Now, this is similar to like an API or a schema, but those are more implementations of a vocabulary for the computer to work with. I'm trying to think more at an abstract level right now. Like what terms am I going to use in the documentation? What words would I use on buttons and labels? Now, to make this a little less abstract, let's think about what the DOM's vocabulary is. I mean, we've got the HTML tags, attributes and properties, input types, events, and also we have the terms that we use for categorizing them. Tags, attributes, props, inputs, events. Those are all part of the vocabulary as well. And I think this is actually the harder part of the vocabulary is defining the taxonomy. It's easy to identify like the concrete terms of the domain, but it's tricky when you need to talk about things that are more abstract or more about categorization. I mean, if you need any example of this, I mean, how many people here know what the difference between an attribute and a prop is? I see one hand. When I was working on this, I feel like I might know what it is. I think it's one of those like instance versus class type things, but I'm probably wrong, and that's why I'm just lumping them together. Now, another challenge of managing the growth of a vocabulary over time is, how do you grow it? How do you grow it in a way that's organic but not haphazard? This is another problem that a lot of people have with the DOM. There are some places where it works out really nice. Like, I think it's nice that all the input types are, that inputs are basically they share very similar interfaces, and then all of the fancier inputs will degrade into a simple text input. But then we also have things like text areas and selects, which are sort of artifacts of the thinking in 1991, where it's like, well, HTML is not going to get any bigger than this. We don't need to add subcategorizations, and they have their own totally different interfaces, and then it adds complexity to have this. Or another example would be the way that we have like 3 different systems for doing document outline. We have like the H1 through H6. We have nested lists, and then we also have the nested sections, and then sections having sections are supposed to have their own document outline, but no, that was never implemented. Now, we encounter a lot of these vocabularies in our day-to-day work. I think as much as we think of programming in terms of like, oh, well, it's STEM, it's all just math and algorithms and stuff. Most of the work that I do, especially maybe just as a front-end developer, is thinking about like the thinking about this from a linguistic perspective, and like maintaining and learning and creating vocabularies. Every domain that we work in has its own terms, and sometimes terms have similar meanings, sometimes terms will have different words for the same meaning, domains that intersect a lot, like the DOM and HTTP will have like will have different terms for the same thing, or weird meshing issues. And at the risk of a circular definition, though, I think that what makes something understandable, what makes something recognizable as a problem domain, is that we can say that we have a vocabulary for it. So before I even get into the implementation of Critterville, I want to think about what the vocabulary for Critterville is going to look like. So I've got my nouns, the entities in Critterville. If I'm going to add another kind of creature, like dung beetles, for example, that would go in this column. But then I have to think about if I'm going to add a lot of creatures or a lot of different fixtures, do I want to break that into subcategories? I also have my verbs. These are the actions that are going to be performed by the user or the critters. I mean, and I have these categorized by subject, but maybe if I have a different kind of thing that can have actions, and I'll need to think about, like, do I want to add this to this set, or do I want to create another layer of taxonomy? And then I have the traits, the qualities that affect the state and the behavior. Some of these are going to apply only to critters, and like fear and hunger. Others, like position, those apply to everything. Poop has a position, even though it doesn't have a lot of other traits. Every poop, for the purposes of Critterville simulation, I'm going to say every poop is the same. That's not actually true. Don't at me. Now, something you may have noticed is that a lot of the vocabulary I've been talking about it's related to the interfaces of the respective domains. These are all terms that I'm encountering as a user of HTTP or of the DOM, not as someone who's building it. I'm sure that a well-organized vocabulary is really useful for the implementers, but it's absolutely crucial for the consumers. And this is because if I'm working in a browser, the only way to interact with the page is through the DOM's interface. I can't write to the DOM's memory. Canvas gives you a little bit of that, but Canvas has its own interface. It's just lower level. In order to work with these interfaces, I need to send and interpret messages that conform to their protocols. Now, for example, let's look at the HTTP, the Hypertext Transfer Protocol, for transferring hypertext. A typical HTTP interaction has the client sends a request, server then sends a response back. So a request, this is what do we have in here? It's just we have the method, which is get, the path, version, and a couple of other headers for metadata. And then we've got the response, which is the HTTP version, a status code, more metadata, and then the actual page that was requested. Another kind of message is, again, with the DOM. DOM events have a different purpose and a different context than HTTP requests because they're on the same computer and the data doesn't need to be serialized into text. But they share a fundamental rationale, communicating between two isolated environments, in this case, the native browser UI and the JavaScript runtime. In both cases, there are security rationales behind this air gap. In HTTP's case, there's an additional goal of network efficiency. But the goals of both these protocols are to enable communication between two parties without intimate knowledge of each other's innards. They only need to speak the same language. In JavaScript, when we deal with these messages, it's often in terms of like events and event handlers, where we run a callback whenever a received message matches a particular pattern. Terminology note, I'm sure there's a distinction to be made between events and messages and actions and all that stuff, but for our purposes, they are basically the same. And I think that this jQuery event listener is how a lot of people first encountered this. This is when I got into web development, jQuery was king. I would have used the native DOM version, but it's actually too long to fit onto a line legibly. This handler is it listens to DOM events of type click sent to that button, and then it calls show menu. We see the same pattern so this is like express. Interesting thing here is this is matching on both the post HTTP method and the path users and ID. And then Node uses the same patterns for signals and streams. And I know if anyone saw the BB8 talk, well, I think the person who gave it isn't here. If you saw the BB8 talk, the inter-process communication works in very much the same way. But that's not the only way that we encounter events in JavaScript. So like React and old school HTML, of course, they have their inline handlers. React also has its lifecycle events. It's because they operate as methods. We don't necessarily think of them as event handlers, but they totally are. In fact, this is how events are handled in most typical object-oriented languages. And then Redux is actions. Those are also another events or messages or whatever. Redux doesn't offer you any sort of pattern matching. That leaves it totally up to the developer. So it just sends you every action to every reducer, and then you're up to whatever, write a giant switch statement to match on that pattern. Now the biggest advantage of message passing is concurrency. Many messages can be in flight at once. This is also one of its biggest challenges. It's as you can see, it's easy to get confused about what messages are in play and create race conditions because messages aren't being handled in the order you expected. So one of the big challenges in development today is how do we manage messages so that we can deal with them in an orderly fashion. Now, another problem that you encounter with messages is that they're not always meaningful in isolation. This is something that we encounter all the time. And think about what a pain in the ass it is to make the flow of form validation feel right. Or, like, have you ever tried implementing double-clicking from scratch? It's a huge pain in the ass. Messages might need to cancel each other out or happen in a certain sequence or within a particular time frame or trigger sequences of other events, like the force traveling through the balls of an executive desk toy. If messages are the balls, what do we call the force? Everyone's seen this ad on Twitter, right? You have no idea how much anxiety this gives me. Anyways, maybe an even more basic question is, where are the messages coming from, and where are they going? Who messages the messengers? Now, I'm gonna call these. Call them processes. What is a process? An entity that sends and receives messages. From an outside perspective, that's all it needs to. It's totally black box. A process's purpose is to contain and confine computation. So you could model something that like debounces clicks into double clicks as a process. You could also model a whole server as one. Now, I named this with Unix processes in mind, but it also describes, web workers have the same interface, like actors in Erlang. Even a lot of the code that upholds these boundaries, like a Redux store. A Redux store has its interface of it reads from dispatch and it writes to get state. Of course, a lot of languages that have their term for an entity with private state that communicates through message passing is an object. You know what else fits this model? Oh boy, it's microservices. So every time I give this talk, I feel like I understand microservices less and less. It appears to be you take a big box and you split it into a bunch of little boxes. And sometimes the boxes are hexagons. And of course, now microservices are totally passe. I think the next time I give this talk, I'm going to have to change it into how is an ant farm like serverless architecture. But the technical reasoning behind microservices is that by splitting up a monolithic server into a bunch of little independent ones, you have more flexibility for scaling and redundancy. But the stronger motivator behind this kind of architectural rewrite is to enable, or I guess force, team independence. Now, why do we want independence? Is this like a libertarian thing? It's definitely a less familiar way of designing software, and it's a lot more complex. Why are we going to the trouble of encasing every little thing in a suit of armor? We do this because conceptual boundaries enable material boundaries, boundaries across time or boundaries across space. An independent process can be made to run on separate cores or on separate continents. But conceptual boundaries also enable cultural boundaries. Well-defined boundaries allow me to use your software without knowing anything about how it works. That's the same whether we're on different teams within a company or if we're in working on totally different projects. If I'm using your open source work. But there is absolutely a trade-off. These boundaries have a cost, especially if you don't need them. It's easy to look at what's happening now and think that we're seeing a steady trend from centralized to decentralized as monoliths are split into microservices, but we're not. We're just in a downward swing of the pendulum, a turn of the Hegelian dialectic. The React world is on the same cycle, but oddly enough, it seems to be on the opposite phase. So right now, we're actually centralizing state management out of individual components and into a single store. Now, we have the same trade-offs that apply, simplicity of the whole versus simplicity of parts. Where our culture has just, for the moment, decided that the one is more valuable than the other. But maybe this means we can see the future. We know that there's this pendulous motion. We can look at something like Elixir's Phoenix framework and how it employs, it combines things. It's a synthesis. It employs some of the conventions of a Rails monolith, but in a language that is built for fine-grained concurrency and distribution. It's neither as holistically or individually simple as either of the ideas at synthesizing, but the compromise is an improvement over either extreme. So what would this look like for a front-end app? The big performance bottleneck in JavaScript, of course, is single threading. But the big conceptual bottleneck is around managing UI data and networking in a single brain. Now, a specter is haunting front-end development, the specter of service workers. I can see a world where data and network management, or everything that is of interest, or not everything is of interest, everything that is like data intensive in an app gets moved into the service worker that's a completely independent entity from the UI. The UI can become, quote unquote, dumb again. Now, one of the advantages here is like once you've forced the separation of UI and data into like totally different processes, you can put them on different machines. I mean, maybe this is the step that we need to take another crack at, like the Meteor or the Hoodie approach of having synchronized clients and servers. And now something occurred to me as I was working on this. If I have critters running over the network, does that mean I'm making a massively multi-critter online rodent petting game? Sorry. Oh, wow, that was a lot of stuff. I feel like we just went through one of those like 50s shorts about like, oh, gee whiz, I didn't realize springs were so important, except about message passing. But I think that JavaScript has been going through an interesting cultural shift in the last, like 3 years or so. Now, we've never had a particularly strong culture around object-oriented programming. I mean, you just don't see talks about design patterns or solid principles at JavaScript conferences. But we've been getting more and more interested in functional programming, first with underscore, and then with underscore doing it wrong. The things really took off with React. And now there's a bunch of JavaScript developers, still a minority, but a hell of a loud one, getting interested in like immutability and referential transparency and monads. And compiled JS languages like ClojureScript and Elm are bringing this to the browser, and they're granting us humble JavaScripters a glimpse into this futuristic world. But along with that comes dogma. Now, of course, there's the usual suspects with my paradigm can beat up your paradigm. I mean, what can I say? Redditor's gonna Reddit. But we've also got seemingly respectable members of our community saying that if you use classical inheritance, your company will go out of business. But JavaScript it's fundamentally incompatible with ideological purity. If you want to go full on year zero, there have never been more options to choose from. But JavaScript is necessarily a big tent language that has to solve needs beyond our own. Hey, JavaScript has to continue to solve the needs of people going back to 1995, so that we don't break the web. And as far as object-oriented programming goes, I think there's a lot of useful wisdom in the last 40 years of study. The date on that last screenshot is October 12th, 1977. We should think about how we can synthesize that with our newfound love of functional programming. And this was my big awakening with React and Redux. Component renders and store reducers, those are pure functions, no side effects, no mutations. But everything supporting them is the opposite. The React component state and life cycle, Redux's subscribe and dispatch, those are all about side effects. React and Redux aren't a rejection of object-oriented programming so much as a reinvention of it. And instead of thinking about functional and object-oriented programming as competitors, we can see them as operating on maybe different parts of the problem or at different scales. We can stop thinking about objects as smart data structures and start seeing them as systems for coordinating communication. Processes, microservices, actors, workers, bureaucracies, guinea pigs, a zombie with no conscience. Wait, not the last one. What does it mean when we can see all of these through the same lens? It means new avenues for understanding, new possibilities for collaboration. The vocabulary of front-end development becomes so much richer when we can adapt patterns and terminology from distributed systems into client-side apps running across web workers. And the scales fall from our eyes, and we can finally see how the Internet of Things is just object orientation made horrifyingly literal. JavaScript's defining characteristic, whether for good or for ill, is that it is always accumulating, never removing. But this is how society functions. You can't roll back the clock. You hope to God that you don't have to start from scratch. You just keep moving forward. And just as event sourcing is where current state is a left fold over previous behaviors, society is a left fold over ideas. And dogma is toxic to a society. Dogma is terrible. It is toxic to culture. And we need to be thinking about. We need to be seeking out new ideas, but we need to be synthesizing and compromising those ideas into our prior knowledge and experience. Because, hey, you never know when the new idea you've discovered actually uncovers the hidden wisdom of everything before it. Thank you.